Hello everyone, hope you all are doing well. Because of this COVID-19, hope everybody is staying at home and everybody is safe. And I am yet again before you to continue with the next class. In the previous class, we have discussed about the basics of light, the characteristics of light, and the phenomena. One phenomena of light we have seen, that is reflection. And today, let us deal with the laws of reflection. Okay, so in the last class I did say that we will be dealing with the mirrors. So first we will deal with the laws of reflection and then we will be dealing with the mirrors. So now, in order to know the laws of reflection, let me take you through a drawing. Okay, let us say that this is the reflecting surface. Okay, see, this one is the reflecting surface, the upper one, and this is the shaded portion. So whenever we incident a light, okay, let me take 2 points. If I take okay, now the light incidents on this surface, on this reflecting surface. This is the incident ray, that is, let me name it as AO. AO is the incident ray. And now, as and when this incident ray AO strikes or falls onto this surface, this ray is going to change its direction. That is, it is going to bounce back. And that we call it as reflection. And let me name it as point B. Okay. So here AO is the incident ray, O is the point of incidence. From O, that is from the point of incidence, the light ray is bouncing, is returning back, right? It's returning back, it is reflecting. This OB is called the reflected ray. So as and when the light is incident on a surface, reflecting surface, the light ray is bounced back, or the reflection takes place, and this bouncing back of light we call it as reflection. Okay, so now OB is the reflected ray. Okay, so now if I have to say this is the surface, okay, this is the surface and this is the incident ray. So suppose if I name it as the surface as XY is the surface. This angle AOX is called as surface angle or a glance angle. Okay, these two, angle 1 and angle 2, you can call it as surface angle or glance angle. So the angle between the surface of the reflecting surface and the incident ray or the reflected ray. Okay, so here the angle between the incident ray and the surface of the reflecting surface is called as glance angle or surface angle. Okay, now what I am going to do is, now I am going to draw a normal means perpendicular. I am going to draw a perpendicular line, a normal okay. Now this is the normal, let me name it as N. Okay, NO is normal to XY. That means NO is perpendicular to the reflecting surface XOY. Is that clear? So this NO is perpendicular to this reflecting surface XOY, which means that the angle NOX and NOY, these two are right angles. These two are right angles. This makes 90 degree. Is that clear? So this angle here. This is 90 degree NOX and also here. This makes 90 degree. Is that clear? NOY. Is that clear now? Okay. Here, since this AOB is angle between the incident ray and the reflected ray. Okay. AO is the incident ray and OB is the reflected ray. So the angle between, AOB, that is the angle formed AOB, or the angle between this incident ray and reflected ray, okay, you could see that is angle AOB. The angle formed between the incident ray and the reflected ray is angle AOB. When we have drawn normal NO to this surface, reflecting surface XOY, this normal NO divides angle AOB into two equal parts, into two equal angles, that is AON and NOB. Is that clear? I'll repeat it once again. This normal NO is bisecting angle AOB. This normal NO, which is normal to the reflecting surface XOY, is bisecting angle AOB. Bisecting means it is dividing into two equal parts. Okay. Now, since it is divided into two equal parts, that means angle AON, that is angle AON will be equal to angle NOB. Will be equal to angle NOB. So angle AON is equal to angle NOB. Is that clear? So here, now what is this angle AON called? Angle AON is called angle of incidence. Angle of incidence. How to define this angle of incidence? This angle of incidence AON is the angle made between AON, right? That is the angle between the incident ray AO and normal NO is called angle of incidence. Is that clear? So the angle of incidence AON, right here AON. So in general, the angle of incidence is the angle formed between the incident ray and normal. Okay? So that is angle of incidence, and this is denoted by I. Okay? This is denoted by I. Angle of incidence. Similarly, this one is angle of reflection. This one is angle of reflection, right? That is NOB, right? NOB is angle of reflection. NOB is angle of reflection, and it is denoted by R. It is denoted by small r or lowercase r. So this angle of reflection, how do you define angle of reflection? Angle of reflection is the angle formed between the normal and reflected ray. Normal and reflected ray. This one. normal and reflected ray. So the angle formed between the normal and the reflected, that is NOB. Okay, angle, either it should be named by three vertices, that is NOB. So the angle which is forming, that has to be in the center, or simply you can say angle O. But here we have two different angles. There are two. This NO is bisecting two angles. So let us keep it as 3. Let us name it by 3 vertices, NOB. Okay. So understood now? So AON is angle of incidence, because this AON is formed between the incident ray AO and the normal NO. And NOB, angle NOB is angle of reflection, because this angle NOB, this angle of reflection is formed between normal NO and reflected ray OB. Is that clear? Yes. So by this, okay, so by, see, we can see here AO, this is the incident ray, AO is the incident ray, right? AO, ray O is incident ray, NO is normal, that is, you can call it as perpendicular. OB is reflected ray. Is reflected ray. Okay. So AO is incident ray, NO is normal, OB is reflected ray, and O is point of incidence. Point of incidence. Okay, point of incidence. Now you could see this incident ray AO, normal NO and reflected ray OB all lie on the same plane, of reflecting surface at the point of incidence. At the point of incidence. They all are on the same plane. They are not on different plane, right? They are on the same plane. This is the plane. Reflecting surface XOY is the plane. So all are going to emerge from, or they are going to meet from that point itself. They all are going to lie on the same plane, that is at the point of incidence. So AO, NO and reflected ray OB. Okay. So the incident ray AO, the normal NO and the reflected ray OB, all the 3 rays, okay, all the 3 will lie on the same plane XOY at the point of incidence. Okay, plane. So this is a board. If I am going to write on this board, then this is all whatever I have written will be on the same plane. Okay, because it has got a boundary. So with one boundary, we call it as one plane. Okay. Suppose if I have to say you, if I have one more box the other side, suppose, see here. So suppose if this is one plane, and let me consider this as another plane. If I am writing 1 here and 2 here, and if I write 3 here and if I write 5 here, which means 1 and 3 are on one plane, 2 and 5 are on other plane. Is that clear? So they are not on they are on different planes. Clear? So this is the example for the plane. So it has got its own boundary. This 1 and 3 are lying within one boundary, 2 and 5 are in another boundary. Okay? So they are two different planes. So here this XOY acts as a plane. So all the incident ray AO, the normal NO and the reflected ray OB, all the 3 will lie on the same plane XOY at the point of incidence. Okay, and this is the first law. So what is the first law? first law is first law of reflection is the incident ray the normal and the reflected ray all lie on the same plane at the point of incidence. Okay, this is the first law. What is the second law then? What is the second law? As we have seen here, this angle of incidence will always be equal to angle of reflection. Angle of reflection. Okay. So angle of incidence will be equal to angle of reflection. So in the second law, what is the second law says? So angle of incidence is always equal to angle of reflection. Is always equal to angle of reflection. So these two are the laws. Okay, these two laws hold good for any type of reflection. It might be a regular reflection or it might be an irregular reflection. Okay, no matter, irrespective of the medium, whatever the medium it might be. Okay, the reflection, either it is, even if the light ray is made to incident on the polished surface or unpolished surface, these two laws, okay, the first law and the second law of reflection holds good for all the reflections, for all types of reflections. Okay, is that clear? Or all types of surfaces. So wherever the light is reflected, so there the incident ray, the normal and the reflected ray all lie on the same plane at the point of incidence. And the second law, the angle of incidence is always equal to angle of reflection. Okay. So suppose if the angle between the incident ray and the reflected ray is 80 degree. Okay. If the angle between, that is angle AOB is 80 degree. Angle AOB is 80 degree. Then what would be the angle of incidence? Is your question. Okay. This is the question now. If the angle AOB, is 80 degree, then what will be angle of incidence? So what you will do here? So angle AOB is formed between incident ray and reflected ray here. So if it is 80, then we know angle of incidence and angle of reflection are same. They are equal to each other. So divided by 2. So 80 divided by 2 is 40. So angle of incidence is 40 and angle of reflection will also be equal to 40 degree. Suppose if they give the glance angle, if the glance angle to the surface is, if they give it as 30 degree, if they give it as 30 degree, if the glance angle is 30 degree, that is XOA is 30 degree, then what will be the angle of reflection? He is asking angle of reflection, this one. So you know that this glance angle and angle of incidence will be equal to 90 degree. That is XOA plus AON. XOA and AON will make 90 degree, right? Yes or no? So XOA plus AON will be XON, will be angle XON. XON is 90 degree. So 90 minus 30 will be angle of incidence, that is 60 degree. So angle of incidence is always equal to angle of reflection. So therefore angle of reflection is also 60 degree. Is that clear? Hope you have understood this law of reflection. Okay, so now we will move on to the mirrors. Now we'll move on to mirrors. So in mirrors, if we have to talk about the mirrors, we use mirrors at our houses to see our face, right? And we use mirrors in vehicles to see whenever we are taking the curve, when there is a curve, or if we are going to change the direction. Okay, that is like taking a turn. If you are taking turn, or in a traffic, if you are taking a reverse, if you are taking our vehicle reverse, okay, so then we will be using the help of, we'll be taking the help of mirrors. So are we using the same kind of mirror everywhere? You might have seen, if you go to the doctors, the dentist, okay, he too will be using a mirror, right? So what kind of mirror are they using? We are using mirrors in the solar cookers and all. So what kind of mirrors? Are we using the same mirror, or we are using different types of mirrors? Okay. So now we'll shift to the topic mirror. What is mirror? Mirror is an optical instrument. It is an optical instrument. Okay. It is an optical instrument okay, whose one surface is made reflecting and other opaque. It's an optical instrument. Okay. Mirror is an optical instrument whose one surface is made reflecting and other opaque. Now if I have to deal with what is this opaque? Opaque, which will not allow light to pass through it. Opaque means what? The object which is not allowing any light to pass through it. Okay, that means will be not, if a light passes through it, then we'll be able to see. If the light is not able to pass through it, then it is going to reflect. Okay, so that is opaque. You can take wood. Okay, wood is an opaque object. So here mirror would be an opaque object. Okay, mirror is also an opaque object. Why? When they take a transparent piece of glass, okay, and glass, on that they will be doing coating. Okay, silver coating they will be doing, and on silver coating, that silver coating will be protected by a red paint or a grey paint. If you have seen a mirror, the back of the mirror, if you see any, or if you take any mirror and if you see back of the mirror, you could see some will be painted grey color and some will be red color. Okay, and behind that, beneath that color, that red color, you will have a reflecting, that is a reflector they will be using. Okay, it might be an aluminium or a silver coating. So earlier they used to use silver coating because silver is considered as the best reflector, and to be like, as the aluminium is bit reasonable, so they are using aluminium in order to coat. Okay, so one surface is made reflecting and the other is kept opaque. So that is the mirror. Now if I have to tell you that, as we have, like as I was telling you, okay, before going to the mirror, I was telling you about there could be, like we are using mirrors in the bathrooms, okay, to see our faces. We are using the mirrors for the vehicles to see, to take while taking a turn and all, right? We are using even the mirrors that are used by dentists. We are using in solar cookers and all. Are we using the same type of mirror, same kind of mirror everywhere? If to discuss that, the answer from my side would be no. We are using different types of mirror. There are different types of mirror, and they are there are two types of mirror. One is plane mirror and the other one is spherical mirror. One is plane mirror and the other one is spherical mirror. Now, how do you differentiate between plane mirror and a spherical mirror? Okay, how do you differentiate between plane mirror and a spherical mirror? Plane mirror, you could see, if I take this scale, okay, the surface of this mirror is, the surface of this scale is flat, right? It is flat. So again, mirror, don't confuse. Mirror means always one thing should come in your mind. That is, one side will be reflecting surface and the other will be opaque. So here also you should think that this is the shaded, okay? This is opaque, and assume this as the reflecting surface. Okay, this is the reflecting surface, and this is the back side is shaded. Okay, so here the front one, this is the reflecting surface. So you can see this is very flat. Okay, the mirror, okay, the mirror whose reflecting surface is flat or plane, we call it as plane mirror. We call it as plane mirror. The mirrors that we use at our house. Okay, so that is a plane mirror. So to see or if we go into any jewelry shop, when we wear the jewels and all, to see ourselves like how it is looking, so that is also a plane mirror they use. Okay, and even in the shops, the garment shops, okay, when you see like whether the shirt and the pant, the clothes that you are buying, okay, if you go for a trial, in the trial rooms and all, the mirror that is fixed is the plane mirror. Okay, those are the examples of a plane mirror. Okay, the plane mirror is the mirror whose reflecting surface is flat, is called as plane mirror. Okay, if I have to show, then I can draw like this. Okay, the reflecting surface is flat here. Then, okay, what is a spherical mirror? Okay, spherical mirror is a mirror, okay, is a mirror whose shape is sphere shape, a spherical glass. Okay, so here this spherical mirror, okay, it has two parts, okay, whose surface is curved. So spherical mirror means what? The mirror whose surface is curved, who has the reflecting surfaces, whose reflecting surfaces are curved. They are called as spherical mirrors, and these spherical mirrors are part of a hollow sphere. They are a part of a hollow sphere. Okay, suppose if I have to draw and show you, if I consider this as a hollow sphere, okay, these spherical mirrors are part of this hollow sphere. Okay, are part of this hollow sphere glass. Okay, hollow sphere are the part of this hollow sphere glass. How? So when you divide this, okay, when you divide this hollow sphere glass, okay, when you divide this hollow sphere glass, this is divided into two parts. This is divided into two parts. This is divided into two parts. Okay. This hollow sphere, okay, if I am going to take this one and shift it downwards, if I am going to shift this downwards, one will be like this, okay, and this one also slightly I am going to shift it downwards, and here it will be like this, right? So now you can see these two mirrors, okay, are part of hollow sphere, okay. They are called spherical mirrors. They are the part of hollow sphere. They are the part of hollow sphere, and they are spherical mirrors. And you can see their reflecting surface. If I take this as reflecting surface, this much is the reflecting surface, okay. The reflecting surface of these spherical mirrors are curved. They are curved, okay. They are curved. So if I take the first one, then you can see here that it is curved outwards and this is curved inwards, okay. So here these two types of spherical mirrors, okay, these two type of mirrors, spherical mirrors, are a part of this hollow sphere. When I separate them, I can see one is curved outwards and one is curved inwards, okay. So what are these two types called? So these spherical mirrors, in spherical mirror there are two types. What are they? One is concave mirror and the other one is convex mirror. The other one is convex mirror. Now, which one is concave mirror and which one is convex mirror? How to identify this? Now you can see this, okay. Now you can see here this one, this mirror, this part of mirror, okay, this part of mirror, this part of a spherical mirror, this one, okay, spherical mirror. This is curved outwards. That means if the reflecting surface is curved outwards, that means this would be the reflecting surface and this one would be the shaded one would be non-reflecting surface. The shaded one will be non-reflecting surface, okay. And this is curved inwards, okay. So this one would be the non-reflecting surface, and the inside one will be the which is curved inwards, right? So the reflecting surface here is curved inwards and here the reflecting surface is curved outwards. So the reflecting surface which is curved inwards, we call it as concave mirror, and the reflecting surface which is curved outwards, okay, is called convex mirror. So if I have to explain you that, you can take the simple example that I would like to give you is about your palm. Take a palm, okay, and hold it facing the palm towards you, okay, and make it a curve, slight curve, okay, like this. Now you see this is the palm, okay, this is the reflecting surface, and now this acts as a non-reflecting. This is curved inwards, this is curved inwards, this is curved inwards, right? So the reflecting surface which is curved inwards, okay, is called as concave mirror. It's called as concave mirror. See here, concave mirror. And if I show you like this, okay, now this one is curved outwards, right? So this one is curved outwards. So this acts as a reflecting surface and this acts as a non-reflecting surface, and this is called as convex mirror, okay. So the bent in surface, okay, that is the reflecting surface, okay. The reflecting surface which is bent in is called as concave mirror, and the reflecting surface which is bulging out, okay, the bulging out surface is called as convex mirror, okay. So this is all about the concave and the convex mirror. Is that clear now? Okay. Now, in order to, as I said, these are the parts of a spherical mirror. The center of this sphere is called as center of curvature. The center of the circle, right? Similarly here, center of the spherical mirror. The center of the spherical mirror is called as center of curvature. Is that clear? So hope these all. So what is mirror? What is spherical mirror? What are the types of mirrors? The plane mirrors and the two types of spherical mirrors, concave mirror and convex mirror, is understood. Okay. Now moving on to the next topic. Okay. Now we will see in the plane mirrors. Okay. the characteristics of plane mirror. So what kind of image is formed? Okay. So we will see the image formation later on. Before the image formation, let us understand the terminologies of a spherical mirror. Okay. Terminologies of a spherical mirror. Okay. If this is a spherical mirror, okay, first let me take a concave mirror. Okay, let me take a concave mirror. Let me take a concave mirror. So today we will deal with this concave mirror. Now, the outer surface is shaded. The outer surface is shaded, and this, the bending surface, is the reflecting surface. If I take the center of this sphere, okay, this is spherical mirror. Just you have to concentrate on this part, okay, on this part. The center of this spherical mirror is the center of curvature, okay, is the center of curvature, and this will be the reflecting surface. This is the reflecting surface, and this is M and M dash, and this we call it as aperture. We call this as aperture. M dash is called as aperture. M dash is aperture. C is the center of curvature. C is the center of curvature, okay, and this is the reflecting surface. So what is aperture? Aperture is, okay, aperture. What is this aperture? Aperture is the portion of reflecting surface of a mirror. Okay, this is the M dash is the portion where the light is going to reflect. So the portion of this reflecting surface of a mirror, we call it as aperture. Is that clear? And C is the center of this sphere, so we call it as center of curvature. Okay, it is called as center of curvature. Okay, now if I have to draw, so if I take a point, center of this reflecting surface, center of this M dash, center of this M dash, okay, and I'll name it as P. Okay, the center of this aperture, center of this reflecting surface M dash is represented as P, and it is called as pole. P is the center of the reflecting surface, okay, and it is called as pole. It is called as pole. So P is the pole, that is center of reflecting surface. C is the center of curvature, okay, that is center of the hollow sphere. Okay, if I am going to draw a straight line, if I am going to draw a straight line passing through the center of curvature, passing through the center of curvature and the pole, center of curvature and the pole, okay, so this line, a straight line passing through the center of curvature, passing through the center of curvature, passing through the center of curvature, C and pole, okay, is called as principal axis. Is called as principal axis. Okay, the straight line passing through the center of curvature and pole of the mirror is called as principal axis, which is denoted by XY. Okay. XY is the principal axis. Is that clear now? Okay. And the midpoint of this CP, okay, and this here, see, this is the circle. So CP, now the line joining the center of curvature and the pole is called as radius, right? So CP is the radius, so this is called as radius of curvature. CP is the radius of curvature. CP is the radius of curvature, okay, and midpoint of CP is F, that is called as, this point F is the principal focus, and the distance from F to P we call it as focal length. The distance between the principal focus and the pole is called as focal length. Okay. So in the next class we will be dealing with what is focus, that is principal focus F, okay, and we will try to understand the focal length, okay, the relation between the focal length and the aperture. Okay. So suppose if I draw if I draw a straight line that is perpendicular, a normal, if I draw a normal, okay, if I draw a normal, okay, if I draw a normal, then this one, okay, this one is called as aperture, this angle, okay. So if the curve, if it is more curve, okay, if it is more curve, then angle of this aperture will be increasing. If it is going to, if the curve is going to decrease, then aperture will also decrease. Suppose if I am going to take it back, okay, like this, so then finally aperture will decrease. If I am going to make curve, then the aperture is going to increase. So with this itself, okay, with this relation, okay, how this curvature is increasing or decreasing, based on that only the focal length will also be decided, whether it is small or larger or smaller or greater. Okay, is that clear? So this is the topic that we would be dealing in the next class. Is that clear? So hope that class, so whatever has been explained here, it is clear. So in order to wind it off, once again I will be dealing with this. So this is a spherical mirror. C is the center of curvature, P is the center of reflecting surface, we call it as pole, and CP is the radius of a sphere, so we call it as radius of curvature, and F is the midpoint of CP, so that is the principal focus, that acts as a principal focus. And since the reflecting surface is curved inwards, this is the concave mirror, and the line passing through center of curvature and the pole of the mirror, we call it as principal axis, that is X, Y. Is that clear? Okay, so these are the things, so you can go through this video, okay. So whatever the classes, whatever the topics that we have covered today, okay, so try to understand that, okay. If you are not understanding in one go, please view this video again and again, okay, till you understand. And once you are thorough, okay, so then try and understand, to put some practical applications on that, and so that you can understand in a better way, okay. So today we have discussed the plane mirror, the types of plane mirror, and the laws of reflection also. So these all you have to make it clear, because this is not only going to help you for the 10th standard, this is the same things that you are going to read in the second year also, in the ray optics topic, okay. So we see you all in the next video, okay, so with the further terms and all related to the spherical mirror. Thank you so much, you have a great day.